R1 and R2 are connected in parallel, and they are giving us the equation. We don't have to come up with it. So it's 1 over R equals 1 over R1 plus 1 over R2. Fine. If R1 and R2 are increasing at rates this, what is this telling us? I have to stop and make sense of this. So I have a 0.3 ohm per second, and I have 0.2 ohm per second. What do these represent? And then the trap. The trap is after when? I'm not going to write it right now. I just need to identify what this represents. I need to see what this is. I need to make sure that I know what that is, and then I'll continue reading, not before.
Is that dV over dt?
So let's look again. If R1 and R2 are increasing at rates of, respectively,
R1?
it's a rate of change. I cannot write R1. It's a rate of change.
dr dt?
dr1 over dt. Awesome. Yes. Great. And?
dr2 over dt.
Very good. Awesome. Now we can read on. How fast is R changing? Trap. R1 equals 80. R2 equals 100. I need to identify what I'm asked, because otherwise I don't know, I'm going to go around in circles.
Can you please say the question again?
Yes, of course.
R?
So, how fast is R changing?
The R?
How do I write it?
dr over dt.
Excellent. So how fast is R changing when blah, 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 we don't care. That's the trap. It has to wait. Good. In this case, I don't need the figure. It's right there. I don't need an equation. It's given to me. Okay? All I need to know is that this is a function of time, this is a function of time, and this is a function of time. Okay? So I will change this into R to -1, of course. I will change this into R1 to -1, of course, and I will change this into R2 to -1. And I'm ready to differentiate. Ready? So how do we differentiate this?
negative 1 over r squared.
Right.
The r dt. Negative r1 is from negative 2. The r1 dt plus. Isn't it plus?
I'm sorry.
It was like a positive sign.
I couldn't hear you. Can you say it again, Victoria?
Isn't that plus, not minus? No, like before the R2, yeah.
You mean from here?
Oh, you're right, sorry.
Is that okay?
Yeah.
We are asked to find this, so I'm going to divide both sides by this. But of course, I'm going to change it into positive because they're all negative. So I'm going to multiply both sides by negative 1. And now I have the r over dt, r to negative 2, r1 to negative 2, dr1 over dt, and plus r2 to negative 2, dr2 over dt. So now let's see what we are given. We are given when r1 equals 80 and r2 equals 100. So we have this 80 to negative 2. We have this 0.3. I have this 100 to negative 2. I have this 0.2. I don't have this. Not a big deal from the equation. So 1 over r equals 1 over 80 plus 1 over 100. I have to solve for r. For this instant, when r1 is 80 and r2 is 100. Why? I have all these, but I don't have this for this instant. So I have to find the r first. So 1 over r, the least common denominator. So what is the least common denominator here? So 80 will be 2 to the 4th times 5. 100 is 2 squared times 5 squared. And I need 2 to the 4th times 5 squared. So this is 16 times 25. What is 16 times 25? Lazy people, use a calculator. What is 16?
400.
Is it?
400.
Okay, thank you very much. Thank you, thank you, thank you. Where are you guys? Okay, so it's 400. So then this one needs 5, and this one needs 4. So this is 9 over 400, and I flip. So then r equals 400 over 9 ohm. Okay, so finally, the r over dt is 80 to negative 2 times dr1, 0.3, plus 100 to negative 2 times 0.2. And in the denominator, we have 400 over 9 to negative 2. Now, I have to be very careful how we plug this in. Very careful. Okay. I'm going to share my screen. Where is my screen here? Okay. Good. So, parentheses for the numerator. 80 to negative 1. I'm sorry. It's actually negative 2. I thought I would get away with that, but nope. Multiplied by 0.3 plus 100 to negative 2 I didn't put parentheses here. You may not need it, but I have to be consistent. Okay. Times 0.2. Close. Divide by, in parentheses. I don't know if I need 2 sets, but I'm going to put 2 sets. 400, probably not. The calculator, I think it will do this correctly. To -2, and then close another parenthesis. I think it will do it correctly, but just to be on the safe side. Okay, so the answer is 0.1321. Measurement unit. Measurement unit.
Ohms per minute.
Second. Very good. Awesome. Well done. Okay, I think we have 4 minutes left, so allow me to at least start one more problem. If we don't have time to finish it, we'll finish it on Wednesday. And we had plenty of different situations, enough, more than enough. It's fine. I think we're okay. I'm thinking of a problem. We did some particle. We did that. Okay, 19. I promise to stop in exactly 4 minutes or less. A man starts walking north at 4 feet per second from a point P. 4 feet per second. We stop. So I'm going to call this y. What is this? So it's going up, covering distance y, and the rate of change is 4 feet per second. What is this?
dy over dt.
Of course, dy over dt. Read on. 5 minutes later, a woman starts walking south at 5 feet per second from a point 500 feet due east of P. Again, feet, and it says 5 minutes later. Take notes. And she is walking south. I'm going to call this x, her distance covering. And what is 5 feet per second?
dx
dx
dt.
over dt.
Excellent. Good. We identify everything so far. We are dissecting everything. At what rate are the people moving apart? Trap, 15 minutes after the woman starts walking. At what rate are the people moving apart? Okay. We're going to call this V for Victoria. So here's the situation. This one starts, 5 minutes, 5 minutes. Now, start. So this is the distance between the two people. Okay? So what are we asked to determine? And what is this 15 minutes? And I'll stop. We're not going to do anything beyond this. We're going to finish it on Wednesday. I meant to write this.
dv
dv over dt when 15 minutes. What is this? What from here is this?
v
Trap, because how can they give everything in feet per second but then the time in minutes? So that's a double trap. Good, we'll stop here, I promise.